Okay, so this is graphing circles in parametric mode. First, draw a circle. This is one of the best things about this thing. And get a good circle. Okay. Put it on a coordinate plane. And if I locate a point on the circle, okay, and drop the perpendicular, this should remind you of the unit circle that we did in trig. Okay. I want a unit circle, and when they talk about a unit circle, they're basically telling you the radius is equal to 1. Might be 1 inch, might be 1 mile, but it's equal to 1. Okay, let's label this angle as theta. Label this distance as x. This distance is y. And this distance is r, the radius vector. Okay. This ordered pair then would be x, y. And Pythagorean theorem says x squared plus y squared equals r squared. Okay? And in this case we could substitute in 1, and you could solve for y and graph that. It's going to be a circle with a radius of 1. Okay, if we go back to our trig and figure in this triangle cosine of theta. Now, check the memory banks. Cosine, what's the definition? Yeah, adjacent over opposite. So our adjacent in this triangle is x. Sorry, I said opposite. Hypotenuse, sorry, that's my fault. Sorry. Whoa, whoa. Yeah, that was my fault. I was thinking one thing, said something else. Cosine of theta equals x over r. Okay, now if I said solve this for x, you can multiply by r on both sides, or you can think of this as over 1 and cross multiply. X would equal r cosine of theta. Do the same thing with sine. Sine of theta in this picture, sine is opposite over the hypotenuse, y over r. Same thing, solve for y. If you cross multiplied or multiply by r on both sides, you're going to get y equals r sine of theta. You already have these two formulas on your card from last year. We did them when we did polar graphing. Remember when we did the cardioids, the lemniscates, all of those? Yeah. Those are two formulas that you can use to convert from the rectangular to the polar back and forth. Okay. If I go back and sub in to this, sub in my x, I'd have r cosine of theta, quantity squared, okay, and then if I sub in for y, plus r sine of theta, quantity squared, equals, but in this I'm using a unit circle, so r squared would just be 1 squared. Okay? And I could substitute in 1 in for r. So if I sub 1 in for r, then I'm actually at cosine squared theta, sub 1 in for r, and I'd have sine squared theta. And remember this? Sine squared theta plus cosine squared theta equals 1. That's one of the 8 fundamental identities that you learned last year. Okay? Okay. Now, using that idea and that information, we're going to take from graphing circles in function mode, you can go to graphing circles in parametric mode. Okay? In parametric mode, last week we did some in parametric mode where the t I did a baseball problem and a golf problem where the T represented the time that the baseball was in the air. Well, now the T is going to represent an angle. T will represent an angle, theta. Okay? And if you graph x equals, okay, and if we subbed in a 1 in for that r, it's just going to be x equals cosine of, instead of theta, we're going to use t, cosine of t, and it's an angle. And that would actually be x sub 1t. And y sub 1t is going to be, because if we put r as 1 in there, our y sub 1t is just going to be sine of t. Now, we have to talk about what mode we're in. We're going to be in parametric mode. And I also want you in degree mode. Clear out any of those equations. Go into mode, go parametric mode, and go into degrees. And if I do a circle, if I wanted to see the whole circle all the way around, is how many degrees? 360. So when I do the window, I'm going to go for my t, because t represents the angle, I'm going to go from 0 to 360 degrees. Okay? And then you have to tell it, let's do for right now, let's just do 1. And let's do for the x, I'm just going to do negative 6 to 6, scale 1. For the y, negative 6 to 6, scale 1. Okay, let's do that first. So put in for x sub 1t, do cosine of t. And it's the t is the xt theta n key. And y sub 1t, do sine of t. We got to do the window. For t, we're using it to represent an angle. So we're going to go from 0 to 360. The step, I'm just going to go, now, it's going to go slow because it's going to figure 360 points and connect them together. For the x-min, I'm going negative 6, x max 6, scale 1. And then negative 6 to 6, scale 1, and graph it. Doesn't go very fast. Now, I purposely set my x and y to be the same so that you can see this does not look like a circle. It looks like an ellipse like this because your screen is longer this way than it is up and down. Okay? So if you really want this to look better, you would do zoom square. And remember, on is a break key too. Zoom. It's going to change the window a little bit, but it will make it look. It'll change these values. Still going to go all the way around. It'll make it look like a circle. Okay? Now, sometimes when you change the t-step too much, it changes your graph. Use the on key. Change the t-step to 10. That'll make it go faster. Goes a little bit faster going around. Okay, and I'm going to change it, do one more thing. Do zoom decimal. Zoom decimal is a user-friendly zoom window. Okay? Okay, so I'm changing this to a 10, and it'll make it go faster. If I change it to 30, the t-step to 30, does it change the looks of the graph? Whoops, sorry, I did 3. Change it to 30 on t-step. Not too bad, but if I change it to t-step to 60, it's only going to plot 6 points. Okay, then it makes it look like a hexagon. Okay, so you need to be careful when you change that t-step too much. Okay, change it back to 10, and that should give us a pretty good graph of our circle. Okay, and now I'm in, I finally went to zoom decimal. That's a user-friendly close-up window. Okay. Okay, what does this R control? What did the R control? The radius of the circle, right? So let's make it a bigger circle. So take an x sub 2t, put in 3 cosine t. And y sub 2t, put in 3 sine of t. And we should get a bigger, leave this one in, put 3 cosine of t. And they always occur in pairs, so 3 sine of t. Got to have both of them to get a graph. Okay, so that just basically made it a bigger circle with a radius of 3. So the 3's control the radius. Okay. Now you can also do the phase shift, left and right. Okay. On the phase shift in trig, when I did a phase shift and I said x plus pi over 4 inside the parentheses, what direction did that move it? It went to the left. It went just opposite of what we think it should go. Now, here's the beauty of parametric. If you do a plus sign in parametric, you would think it should go to the right. Guess what? It goes to the right. Parametric's much better, much easier, I guess I should say. So, in x sub 3t, let's do 3 cosine. Now you got to close the parentheses around the t, and then plus 2. So that's saying take the x value, add 2 to it. Okay? And just leave the other one 3 sine of t. Okay, do that one. So do 3 cosine of t, close the parentheses, and then plus 2, and 3 sine of t. Okay? And it just slides it over to the right. So this is actually it shifts it to the right 2. It's like a phase shift. But the good thing is in parametric mode, if it's a plus sign, it goes to the right. Okay? If I want to go up or down, what would I change? Let's say I wanted to go up 2. If I want to take this original here, and I want to shift the whole circle up 2. Plus. On which one? If I add it to, yeah, I've got to add it to the y. So in x sub 4t, we would just leave it 3 cosine t, and y sub 4t, we're going to do 3 sine of t, and then plus 2. This will do a vertical shift up 2. Okay. And you may have to zoom out a little bit. Zoom 5 or zoom. You still may have to do zoom 6 to see it, and then zoom 5, zoom square. It's gonna be pretty tight. Okay. But you could change the window to see that. Okay. So when you're graphing circles, I think you're going to find parametric modes pretty easy on the circles. Okay, now last week we did finding inverses in function mode. To find an inverse in function mode, you interchange the x and y and solve for y. Okay? Now let's do inverses in parametric. How to do inverses in parametric mode. Same thing I think you're going to see. It's easier in parametric mode. Okay? In I'm going to show you just a regular. We did parabolas last time. We did parametric mode. The original, and remember the original, how you go, like if I said this was y equals x squared in function mode. To graph this in parametric mode, you always start out, let x equal t. Okay, so that's going to be your x sub 1t. And then sub that in. So if we put t in there, my y sub 1t is going to be t squared. Okay? Okay, so let's graph. Okay, in x sub 1t, put in t. And then put in t squared. And let's go 0 to, we're no longer in a circle, so let's go 0 to 5. Step, let's do 0.1. And let's go negative 10 to 10, scale 1, and negative 10 to 10, scale 1. Okay, now, here's where you end up with trouble. Okay, if I did 0 to 5 on my t, if I go 0 to 5, I'm only going to get this much. Okay, I need to change this to like negative 5. And then I'm going to get the other part of it. Okay? Okay. Now, that's the original. Okay? And I went negative 5 to 5.1. And then I just did negative 10 to 10, scale 1 on x and y. This is the one that you got to make sure on a regular, like if it's a parabola or something, you got to make sure you do some positives and some negatives, so you see both parts of the graph. Okay, now that's the original graph. There's my parabola. How to do an inverse. Okay, everybody look up here for a minute. To do the inverse, you just flip these two. Okay, so for x sub 2t, it's going to be t squared. For y sub 2t, it's going to be t. Okay, so this, whoop, sorry, I said it, but I wrote it wrong. T squared, sorry, t squared and t. And graph it. Okay, and it will, it does overlap here a little bit. And it's symmetrical about that line, y equals x. If it's an inverse, it has to be symmetrical about the line y equals x. Okay? Now, it may not look it here. Okay? This looks thicker than this one, so let's do a zoom 5. Square it up a little bit so it looks better. Zoom square. Okay? That is the easiest way to do inverses, is on parametric mode. You just interchange them, flip them. Okay? Now, if my parametric equation, if the original was long, and I did not want to type it all in over again, okay, look at this. This x sub 2t is actually y sub 1t, right? It's actually the same as y sub 1t. My y sub 2t is actually the same as x sub 1t. So if it's a long equation, I would not type it all in. I would go down and use the bars key. So on x sub 2t, do this with me so you get used to this. X sub 2t, get your cursor on that and do vars. You still write arrow over to y variables, but this time instead of doing function, you're going to do parametric. Okay, and we want to pick up y sub 1t. Okay, and then get your cursor on y sub 2t and pick up, you got to do vars, y variables, parametric, pick up x sub 1t. You should still get the inverse. Okay, doing inverses in parametric mode is easier than doing it in function mode, because you don't have you just interchange them. That's it. Okay. Okay. But sometimes if the equations are really long, you may want to do this. And we did the vars key. We did right arrow over to y variables, and then we did parametric. Okay, and found those. Okay. Okay. That's as much as I'm going through. Tomorrow